Ajan, and today we'll be discussing Leetcode question 217 contains duplicates. So the question is about giving an integer array nums, return true if any value appears twice, at least twice in the array, and return false if every element is distinct. So basically we have to check if every element in the array, if any element in the array appears twice or not. So how can we go about it? The first and foremost approach is using a double for loop. Or a loop, any kind of loop. So the approach is something like this. For, let's say, index I, which belongs to 0, that is, this is where the index would start, and will go up to length minus 1. Sorry, it will go up to length minus 1. Yes, that's correct. And inside of it we'll have another for loop for index j belongs to 0 to length. So the idea of using these two for loops is, the first for loop will pick every element in the array, and the second for loop will check the element picked in the first for loop against every element in the array except for itself. So first we need to check if, let's say, the array is array, or as said in the exam question, nums I equals to nums j. So let's say we have found a match. So what we do is, if we found a match, we return true, right? So that's what the program says. But we also need to make sure that this number is not matching with itself. So what we can do is, if I not equal to j, so this is like another if condition inside of it, and then the return statement. Else increment I and increment j as per the loop goes. So this algorithm is something like this. So let's take the first example, 1 2 3 1, as in index 0 1 2 3. So what will happen here is, the element at index 1 will be picked by I. So nums I, so I would be 0 and nums I would be 1, j would be 1, and nums I would be 2. Sorry, j would start at 0, nums j would be 1 initially, but since these two indexes are the same, that is I and j are the same, we do not do anything, we just move to the next iteration. So next iteration, I is still 0, we come over here. So I was here initially, j was also here. Now I is still here, in the second iteration j is here, j is equals to 1. Pardon for my handwriting. So j is equals to 1, so nums I becomes, it's still 1, and nums j becomes 2. These two elements are not same, and as per our algorithm, since these are not same, we won't do anything, we'll just move ahead. So we'll go to the third iteration, I is equals to 0, j is equals to 2. Nums I, nums j. What is nums I in this case? It will remain 1, since this is the outer for loop, and it won't change until j has iterated over all the elements. So nums j becomes, it's at index 2, right? So nums j is 3. Again, these two elements are not same, so there is no match. We move to the next element where I is equals to 0 and j equals to 3. I'll just draw the same array here. So the array was 1 2 3 1 0 1 2 3. So right now I is equals to 0 and j is equals to 3. This is the case that we're dealing with. So if that is the case, what does nums become? Nums I becomes, it's still 1, and nums j becomes 1. Notice that the values are the same and the indexes are different. So our algorithm was the first for loop and then the second for loop. If value match, if index not same, return true, right? Sorry for my handwriting. So this is what we do here then. Since the indexes are different and the numbers match, so that means we have a repeat, right? Repeat of value 1. So therefore we return true. So this is the first approach. Notice that this approach implements two for loop, one for loop over here and one for loop over here, and iterates over the length of the array, which is n. So therefore the complexity of this algorithm is O of n into n, which is O of n square. So this is the first most obvious approach. But now how can we make this approach more better? So let's take another approach. We can take another approach, which is sorting the elements in the array. So if we sort the elements in the array, so let's say nums is 1, 2, 3, 1, and let's add one more element, let's say -1, or let's put 0 here. Let's keep all non-negative, doesn't really matter though. So if we sort this array, how would the new array look like? Sorted nums. Sorry, this is the second approach. Sorted nums, how would it look like? It would look something like this. The first element would be 0, since this is the least element, then 1, then 1, then 2, then 3. Now we can just use, in this case, since all the elements are sorted, so if there is any repetition of any element, it will come right after it, right? So if there's any repetition of just a moment. So if there's any repetition of any kind of element, it would have its repeated part just next to it. So all we need to do is use a single for loop after this for index I, let's say which will iterate from, this is belongs to 0 to length of the array, which is exclusive, or length -1 inclusive. So what we will do is, since we have to check the next element, right? So we need to make a slight modification here, since we need to check up till one element ahead of it. We need to make sure that this part is length -1 exclusive. So basically it will iterate over till length -2. So if nums I equals to nums I plus 1, return true. So in this scenario, this is the algorithm that we need to implement after sorting. So how would this algorithm execute? So this is how it would execute. So let's say iteration 1. So what will happen in iteration 1? I would be 0. So nums I would be 0. And what is nums I plus 1? That is 1. That is 1, right? So this is not equal to this. So we move on to the next part, where, so basically iteration 2, which is I is equals to 1. In this case, nums I would be 1, and what would be nums I plus 1? Nums I plus 1 would be nums 1 plus 1, that is 2, and what is nums 2? That is 1. So now we know that this is a repeated element. So what we do here, we return true. So this is the approach that we're going to use. Notice that if we, in every scenario that we've discussed, if we reach the end of the array and we still do not find a match, then we return a false. So the modified algorithms would look something like this. So I just write in a different color. So let's say if we're both like out of the double for loop and we still haven't got anything, so there we just return false. And similarly here, if we're out of this for loop and we still haven't got anything, we return false. I hope you got the idea. The complexity of this, what would be the complexity of this algorithm? Notice that we're using here just one iteration of the array, right? So the first things that comes to your mind would be O of n algorithm. But notice that this part is of O of n, but where we have to sort initially, so that can vary. So the most quickest way to sort, maybe using a merge sort algorithm, is through O of n log n. So therefore the algorithm would be O of n log n. This is for sorting and this is for searching. So this is how it would look like for sorting, and then for searching. This would eventually turn out to be, since O of n log n is the bigger part, O of n log n. So this is the complexity of this algorithm. How can we improve this algorithm even more? Is there any possibility for doing such a thing? So then we come to a third approach, which is using count sort algorithm. So what is this algorithm about? So it's basically saying that in an array, let's say we have an array 1 2 3 4, right? So what we do is we create a different array. Let's say we name this array count. So this array would have the same length as of the original array, in this case ARR. The only difference would be it wouldn't have the same length, it would have the length of the maximum element in the array. So the maximum element in the array is max ARR. This is just a representation for maximum element in array. What is, and that is that 4. So the length of the count array would be 4. Yes. What is the approach of this algorithm? So this algorithm, let's say, is initially initialized to 0 values for all the indexes. Now for value, let's say in array ARR at index 0, what is the value? It's 1. So we go to the count array and at index 1 we increment that value by 1. So this is from 0, what it was earlier 0, right? So now it becomes 1, which is 0 plus 1. Then we check for index 2 array, the next index of array, which is this. What is the value there? It is 2. So we go to the index 2 of count array. The value here would represent the index of the count array. Now, and we go there and we increment the value, whatever the value is there, by 1. Similarly, then we move ahead to this index 2 in AR array. The value there is 3. So this value would then become the index of this array, and at this index we'll increment whatever there is by 1. So 0 plus 1 is 1. Similarly for this, fourth value in ARR becomes the index of this, and this, at this index we increment the value by 1. So if you have understood this, count sort algorithm is basically just doing the counting the elements, number of elements, the occurrence of the elements in the array. So this is an easy and a neat way to store this information. So how can we utilize this algorithm? How can we utilize this approach to solve our purpose, which was to find that if there's any value in the array that appears at least twice. So let's go back to the example that we had initially, which was having nums. Let's say take this example again, 1 2 3 1. So basically the array is 1 2 3 1. So if we apply the count sort algorithm on this, so how would the count sort algorithm go about it? Let's say we create a different array. First of all, before creating that array, what is the maximum? What is the maximum in nums array? The value 3, right? So this value 3, the maximum value in array, becomes the length of count array. Therefore, length of count array, this would be, yes, so the new count array would look something like this. Count is equals to 0 1 2 and 3. This would be the maximum of maximum index of count array. My bad, so I'll correct that. Maximum index of count array. So now we have got this. So how will we execute the count sort algorithm here? So I'll just write the count sort algorithm here so that we can go over it. So for index I, which starts from 0 and it goes up till length of the array, right? Length being exclusive. This kind of bracket represents exclusive. This kind of bracket represents the square bracket represents inclusive. So once we have that, so iterate. This first loop is to iterate over all the elements in the original array. So I'll just create a variable here. So original value, which is what the actual array we had, in this case nums I, right? Original value is equals to nums I, and then what we can do is, once we have that, as we had discussed, the original value becomes the index of that count array, right? So this would then become the new index would become the original value. Now since new index has, the original value has become the new index, what is our next step? We go to the I'll just highlight this in red so that just a moment. So what we do now is, sorry for my bad. So what we do now is, we go to the count array, we go now to the count array and we go to its new index, and whatever the value was there initially of count at the same index, we add 1 to that, basically saying we found one more occurrence of this value. So this is executing the count sort algorithm, but if at any point of time, I'll just write this in a different color. If at any point of time, if count new index becomes greater than 1, that means it has been counted more than one time, that means it has occurred once, more than once. So then what do we have to do? We have to return true. If this all has, so this is our algorithm for the solution, and if this for loop has finished and we still haven't found an answer, so what happens is we then return false, signifying that there is no repetition of any other element. So this is the algorithm. I hope this algorithm makes sense. You can check the code in the GitHub repository link that I've attached to this video. I hope this helps. Keep coding, guys.